Hello, this will be a short video on piecewise functions. And piecewise functions are really just one large function that takes pieces of different functions. So we've got three different functions here representing f of x. And then over here we have what's called an interval in which those functions are to behave. So the first function, x plus 1, actually is only valid when x's are less than -3. The second one is when x's are between -3 and 0, inclusive, because of the equal to signs. And the last one is only valid where x is greater than 0. The easiest way to graph these is to create a table of values. Pretend that what we have is really three different equations. Y equals x plus 1, y equals 5, and y equals x squared minus 2. And keep in mind that this first line, or this first equation, is some sort of linear line, a linear equation, that is angled. The second one is also linear, however it's a horizontal line. And the third one creates a parabola, because it's quadratic, which is a U-shaped curve, but only over certain intervals. Now in order to pick our points here, for this first one, I'm going to start with the small number, which is -3 for my input. So I have x, y, x, y, x, y. So my first one I'm going to put a -3, and I can choose numbers for x that are smaller than -3. So I'm going to choose a -4 and a -5. So if I input a -3 in place of x, -3 plus 1 produces a -2, and there's my first point. If I input a -4, I'll get a -3 out. If I input a -5, I'll get a -4 out. So what I have here are 3 points that I can actually graph and then draw my straight line. But this first point here was created using the -3. And I'm supposed to pick points that are less than -3. So my first point on the graph there is actually going to be an open circle because it's not actually equal to -3. Go on to the next one. I'm looking for values that are between -3 and 0. So I'm going to pick a -3 to start with for x, a 0 the other side, and then a number in between. And let's go ahead and choose -2. And y has to equal 5 every time, so no matter what I choose for x, my output has to equal 5. So there's 3 points I can graph. And because of the equal to signs, my dots will actually be closed on those points, including those lines. On my last graph, I have to pick numbers that are greater than 0, so I'm actually going to start at 0, but I won't include that in my answer. And then I'm going to pick, let's say, a 2 and a 3. So I input a 0 for x, 0 squared, minus 2 gives you a -2. Input a 2, 2 squared is 4 minus 2, outputs a 2. And 3 squared is 9, 9 minus 2 is 7. So these are the numbers I'm going to use for my graph. So I've copied those answers over here. And one thing I want to keep in mind is this first one has to have x's that are less than -3. So when I put in my first point of -3, -2, 1, 2, 3, -2, which is right here, I'm going to start with an open circle because it's not equal to -3, but that is a boundary line. My next one is -4, -3, so I can actually put a dot there, and I can put a dot here. Now remember, I'm looking for all of my answers that are less than -3. So I'm going to go ahead and draw a vertical dotted line. That's my boundary line. So my line is not allowed to go greater than that for x's. So the rest of my straight line would actually have to go in this direction. So there's the first piece to my piecewise function. The second one has a -3 and a 5, so over 1, 2, 3, and a positive 1, 2, 3, 4, 5. And I am going to close the dot because remember this one was -3 is less than or equal to x is less than or equal to 0. Because of the equal to signs, that dot is actually part of my graph. And then -2, 1, 2, and 5, and 0, 5, which should be here. And my limit on that is 0, so I can't be bigger than 0. So I'm going to go ahead and draw a vertical line. That's my boundary line for my second piece of the function. Then I'm going to just draw my horizontal line between those points. So there's the second one. And the last one has to have x's that are greater than 0. So my first dot of 0, negative 2, 0, negative 2 has to be an open circle. My next one is 2, 2, over 2, up 2, and over 3, 1, 2, 3, up 1, 2, 3, 4, 5, 6, 7. So on this one, I'm going to just eyeball a curve that gets as steep as I can without actually going vertical. And it's all the x's that are bigger than that. So actually what you have is 3 pieces of different functions coming together to create this graph. So that first function that we saw, this one right here, our piecewise function, produces this graph.